Welcome back, friend. In this lecture we will see the properties of charge. So start. Properties of charge. So basically the properties of charge are divided into three different types. In that, first one is what? Additive nature of charge. Second is what? Conservation of charge. And the third one is what? Quantization of charge. These are the three basic properties of charge. So we'll start first of all additive nature of charge. So we will see with example here. Let's consider here we are having an object here. This is a body of an object. Before applying any charge, this body is electrically neutral. This body is electrically neutral. Suppose I am applying here 2 microcoulomb charge on this body. Now the net charge of that body is what? 2 microcoulomb. After some time, I am again applying some charge on that body. That could be, suppose, 3 microcoulomb. That would be 3 microcoulomb. Now, the net charge on that body is what? 5 microcoulomb. After some time, I am again applying some charge or adding some charge on that body. That could be 2 microcoulomb. That would be 2 microcoulomb. So now, the net charge of that body is what? Now this 2, 3 and this 2. After that, applying this 2 microcoulomb, the net charge will be 2 microcoulomb. Then next time we are applying 3 microcoulomb. Now the net charge on that body is 5 microcoulomb. But after that, applying minus 2 microcoulomb, the net charge on that body, that is what? 3 microcoulomb. That is what? 3 microcoulomb. Hence, we know this is what? This is an algebraic sum of charges which are we applying on that object. Let's assume one more example we'll take here. Suppose this is a body. Before applying any charge on that body, this body is electrically neutral, completely neutral. Suppose I am applying here charge Q1, then Q2, then Q3 up to the Qn, up to the Qn. So here the force which we calculate like Q1 plus Q2 plus Q3 up to the plus Qn. So this is what? This is an algebraic sum of charge which we are applying on that body. Okay, the next total charge, that is Q1 plus Q2 plus Q3 plus we just now here we just discuss on the just total charge, not a force. We'll see later what is the force and what is the exact mechanism of that force with regarding to the magnitude of these charges. So this is algebraic sum of total charge we are applying on that body. So here charge is a scalar quantity. You must know this concept, that is what? Charge is a scalar quantity. Okay, so charge may be a two types. That is what? First is basically charge is a scalar quantity, but whenever we use that charge to produce some kind of forces like attraction or repulsion, then it will become a vector quantity. Why? Because of here, only one we think about when a charge, at that time, charge is only a magnitude. That's why it is a scalar quantity. But whenever the direction will be implement or add with this charge, then it becomes vector. We'll see in our upcoming lecture in detail. So right now here we have seen that is what additive nature of charge. Here we are applying some charges on that body. That charge get add together. Whenever the nature of charge will be changed, the effect will be updated here. Again here we will see the algebraic sum of charge which is applied on the body. So we will take next one. So now here we'll see the definition of additive nature of charge. The fact that the total charge on an object is equal to algebraic sum of that charge which distributed over in the object is known as additive nature of charge. जैसे कि हम लोगों ने देखा किसी बॉडी पे या किसी ऑब्जेक्ट पे हम मल्टीपल चार्ज को अप्लाई करते हैं तो वो चार्ज अलजेब्रिक सम के हिसाब से ही ऐड होते चलेगा और नेट चार्ज वैसे ही उस बॉडी का अपडेट होता चलेगा. नाउ we'll see the next concept, that is what conservation of charge. So second content जो है हमारा वो है conservation of charge. So conservation का मीनिंग ही हमें पता है. अगर आप देखो तो डिक्शनरी मीनिंग ही है कंजर्वेशन का संभाल के रखना. कंजर्वेशन ऑफ चार्ज. सो इसका फर्स्ट हम डेफिनेशन भी देख सकते हैं. तो इसका डेफिनेशन ये है conservation of charge only possible on isolate system, isolated system. जैसे कि हमने एडिटिव में देखा वहां पे बॉडी फ्री स्पेस में थी, लेकिन यहाँ पे कंजर्वेशन ऑफ चार्ज में हमें इस हिसाब से देखना होगा कि जैसे कि कोई आइसोलेटेड सिस्टम है, इस सिस्टम का बाहर के एटमॉस्फेयर से या एनवायरनमेंट से कोई रिश्ता नहीं है. Now here we are having two different kind of bodies. Now suppose this body having 2 microcoulomb charge on it, and here this body having suppose 5 microcoulomb charge on it. So the net charge of this whole system is remain constant if the charge will be pass from interchange between them. For example, the net charge of this system is what? 7 microcoulomb. The net charge of this whole system is what? 7 microcoulomb. Suppose after some time we move 1 coulomb charge from this system to this system, then the charge will updated here. Here remain 1 coulomb and here it will get updated with 6 microcoulomb. Still you will see here the net charge will not be changed. It means what? In a conservation of charge, the net charge is always remain constant. So here it's not possible we are applying another charge from somewhere in that system. Why? Because of we are dealing with the isolated system, so there is again no chance to charge move from this isolated system to the another anywhere in the environment or surrounding which is available here. So in an isolated system, charge can be moved with that isolated system or the nearest system which is a part of that isolated system or that network. So here some kind of charge move from this system to this system, then net charge will not be affected. Net charge is remain constant. So the charge may be moved from this system to this system. So in previous time we will see here 1 microcoulomb move this system to this system, then total net charge will not be changed. Now here again we think about we move 2 microcoulomb from this system to this system, then it will updated with 4 microcoulomb and 1 plus 2 this it becomes 3 microcoulomb. Then 3 plus 4 again 7. It means what? In isolated system, if the charge is moved from one device to another or one object to other object, then net charge will not be changed. Why? Because of inner conservation of charge only possible on, or we can say inside of isolated system. So कंजर्वेशन ऑफ चार्ज ये आइसोलेटेड सिस्टम में ही पॉसिबल है, और कंजर्वेशन ऑफ चार्ज में चार्ज का लॉस या यानी हम उसे बोल सकते हैं डिके या गेन ऑफ चार्ज फ्रॉम एक्सेप्ट आइसोलेटेड सिस्टम पॉसिबल है ही नहीं. ओके, देन वी विल सी द नेक्स्ट कंटेंट ऑफ द प्रॉपर्टीज ऑफ चार्ज, दैट इज सो हियर द क्वांटाइजेशन ऑफ चार्ज. हियर द क्वांटिटीज ऑफ चार्ज आर लाइक एज फॉलोज. चार्ज कितने प्रकार के हो सकते हैं? एक है प्रोटॉन, दूसरा है हमारा इलेक्ट्रॉन, और तीसरा है जो है न्यूट्रॉन. ओके, सो यहाँ पे अगर देखा जाए तो ये प्रोटॉन इलेक्ट्रिकली चार्ज होता है पॉजिटिव, मीन्स वी कैन ऑल्सो से प्लस ई. हियर इलेक्ट्रॉन ये इलेक्ट्रिकली होता है नेगेटिव, इट मींस नेगेटिव ई. और इलेक्ट्रिकली अगर देखा जाए तो न्यूट्रॉन ये होता है न्यूट्रल, मींस जीरो, इस पे कोई चार्ज नहीं होता. अब इसका अगर मैग्नीट्यूड देखा जाए तो इसका मैग्नीट्यूड है प्लस 1.6 इंटू 10⁻⁻19 कूलम, और इसका पॉसिबल है माइनस 1.6 इंटू 10⁻⁻19 कूलम. और यहाँ पे कोई इलेक्ट्रिक चार्ज है ही नहीं. Why? Because of neutron is completely neutral, so here there is no any charge on electron. So proton and electron. अब अगर हम किसी भी एटम को अगर देखें, एटम आपको पता ही होगा इस यूनिवर्स में कोई भी चीज या कोई भी ऑब्जेक्ट जो बना हुआ है, एनी ऑब्जेक्ट और एनी like this blackboard, this chalk, everything in this universe made up of with the help of electron, and electron having with the help of atom, with the help of atom, and every atom has definitely having these three things. Suppose here we assume this is an atom of oxygen atom, and we know very well the number of electrons in atoms are 8 electron. With the we are dealing with electrons, so that's why it is negative 8e. And we know very well any atom having equal number of electron and proton. So here if there is 8 electron in the atom of oxygen, then definitely 8 protons are in atom of oxygen. Suppose if I am giving one electron to somewhere from this atom, then here it will updated with 7 electron, and the net charge on that atom is what? Plus e. 1 plus e. Okay, 1 plus e. 1 plus e. If again I am giving another one electron to someone or to somewhere, or remove the electron from that atom, then the net charge on that atom is what? 2e, plus 2e. Okay, so net charge will be updated. Okay, so if we are adding some electron from somewhere in that atom, then net charge will be, suppose I am adding one electron, the net charge will be minus 1e. If again we are adding some electron from somewhere, then this net charge will automatically updated with minus 2e. It means what? Whenever we are donating electron or we are removing electron from the atom, then net charge is positive, or when we are accepting electron, then net charge will become negative. Okay, so here, so after that adding the electron or removing electron, the net charge is what? So after that removing one electron, the net charge is what? plus 1e, then after that adding removing 2 electron, then net charge is what? 2e. Or similarly, when we are receiving electron, then the net charge is what? Minus 1e. After that adding 1 electron, after that adding 2 electron, it becomes minus 2e, isn't it? So here we'll observe here the electron, this e means what? Elementary charge. Okay, this e means what? Elementary charge. And here this 1, 2, these are the integer values, 1, 2, minus 1, minus 2. So here we can say this e is a integral property of charge. It means what? Here this n is what? Integer number, and it will be called as the integral property of charge. Okay, this is an integral property of charge. So we'll take another one example for it. That is what? Suppose if we'll consider here the minimum quantity of charge, then as per the recent research here, this is not a minimum quantity of charge. The minimum quantity of charge, that is what? Quark. So quarks. Here quarks are two types. One is what? Up, and another one is what? Down. The value of up is what? Plus 2 by 3, and here the down is what? Minus 1 by 3. But this is very small, so it's not considerable quantity of charge. So that's why we are dealing with integral property of net charge. So that's why we consider only 1e, 2e, minus 1e, or minus 2e. Such a kind of charges are considered. So here, this is the definition of quantization of charge. The fact that all observable charge means what? Observable charge means what? What we observe here? Minus 1e, minus 2e, minus 3e, or plus 1e, plus 2e, plus 3e. These are the observable charges. Okay. So all observable charges are always some integral multiple of elementary charge. Okay. So this is what? Elementary charge. Integral multiple of elementary charge. So here this is an integer number. It will be multiplied with e. This integer number multiplied with v. Similarly here in a positive approach, these all integer numbers multiplied with multiple of elementary charge, that is what? E is known as quantization of charge, and it will be written as n into e. The multiplication of n means integer number, and with respect to elementary charge, the symbol of elementary charge is what? E. Okay. So is it? Thank you, friend. Please like, share and subscribe my YouTube channel, Dharas Infotech. Please don't forget, press the bell icon. It will help you to notify upcoming videos. प्लीज दोस्तों, इस वीडियोस को 11th स्टैंडर्ड के साइंस के बच्चों के साथ शेयर करें और इस लॉकडाउन में कोविड-19 की परिस्थिति में घर पर रहकर पढ़ाई में उनका सहयोग करें। बने रहे, मिलते हैं जल्द ही आने वाले वीडियो में। धन्यवाद, बाय बाय।